Okay, so hi everyone, Senan this side, and in this video we are going to solve this LeetCode daily problem, which is split linked list in parts. Okay, so this is quite a good question and worthy of a medium level. It's not that difficult, but while writing the code, you have to see the corner cases and implement your solution in that. Okay, so what you would be given is a head of a linked list, singly linked list, and an integer k. So split the linked list into k consecutive linked list parts. Fine. The length of each part should be as equal as possible. No two parts should have size differing by more than 1. This may lead to some parts being null. Okay, we'll see what the meaning of this is when we are going to do the dry run. Okay, so the parts should be in order of occurrence in the input list, and parts occurring earlier should always have a greater size greater than or equal to the parts occurring later. Return an array of the k parts. Now if you see the type signature, the return type, you see you have to return a vector of list nodes, right? The pointers to uh, the smaller linked list, the splits, the head of the splitted linked list basically. So let's look at this test case 1 2 3, and since k is 5, so you could divide it at max into a single list or an empty list or the null basically. Now in this test case you see 1 to 10, you have 10 elements and k is 3, so you could divide the whole list into 4, then 3, and then 3, because the difference between any two of them is 1 or 0, so that is allowed. And also observe the linked list with the size greater than 3 is at the front of the linked list in this case. Similarly, linked list with size 1 is in front of the linked list which is empty. So you have to keep this track, the track of how many elements are there in a particular way, and we'll look at the dry run, and then you'll be able to appreciate the question better. So first of all, let's look at the demonstration for this case. So first of all, we have to decide, is this going to be 3-3-4-3-3 split or 3-3-4 split, 3-4-3 split? We have to understand how do we actually do the splitting. Okay, so here is the linked list, and what we are saying is our k value is 3. So we have to divide this into 3 parts, right? So clearly, first of all, what you'll do is you'll calculate the size of the linked list, which is 10 in this case. So at least how many elements should be in each part? So we have k parts, right? How many elements should be there in each part? So what I'll say is each part should have size divided by k elements, and in the, let's say, the floor value of this. Okay, so in this case, size is 10 by 3, which is 3.33, and if you take the floor of this, you'll get the value 3. So at least every list should have 3 elements, and how many lists should have 4 elements? You would determine that by taking the size modulo k, and this would give you the answer as 1. So this means the first one lists should have one more element. So in this case, we would divide this into first 4, then a size of 3, then size of, so we have, this is k equal to 1, this is k equal to 2, this is k equal to 3. So 3 parts, right? And because this value is 1, so the first part would have 1, 2, 3, and 4, one extra element because of this. Okay, we are good with that. Now once you have figured out that the first would have the size 4, the next would have the size 3, and the next again would have the size 3, how do you actually go by doing this, right? So first of all, let me remove the extra text that we don't require. So we know the first should have 4 size, second should have 3 size, the third should have 3 size again. So the answer that we have to return, the vector that we have to return, should contain this, should contain this, and should contain this node, right? And using this, we can go here and here and here. But if you observe, we have to split the linked list, right? So what we have to do, we have to break these links as well, right? So when, what we would be doing is going to traverse the linked list, and when we know that this is the last node, we'll remove this pointer, and I'll point this to null. Similarly, I'll remove this and point null, and so my vector would be containing 1, 5, and 8, and when you print it, you'll print it till here itself because next is null. Similarly, when you print this, next would, this is the second linked list, and this would be your third linked list. So basically you have to return the heads of these splits. Fine. And the way that we are going to do that depends on the programming language, how you implement that, but logic is this. First you have to figure out size by k and size modulo k. If you have these two information, you can figure out how many elements should be in a particular linked list. Fine. Why does this work? Because size modulo k is always less than k, right? It belongs to 0 to k minus 1. So if that is the case, that means you always have, if you would have an extra node in any linked list, right, it would be in the first k minus 1 elements, right? Now let's look at this example where k is 5 and the number of nodes is actually less than what is expected, right? So what we'll do is first calculate the size, which is 3, and size by k is what is 0 in this case, the floor of this value, and size modulo k, which is the remainder, would be 3. So that means the first 3 elements in the answer list would have the first 3 would have one node extra. Okay, so what I'll do is I'll take this as a part of my answer and I'll reassign this to null. Take this 2 as a part of my answer and reassign this to null again. I'll take this part of my answer and again reassign this to null. Even though this is null, I'm just reassigning it because it makes the code easier. But if you see, we only have 3 groups, right? The answer would be having 1, 2 and 3, but my answer should have 5 elements, right? Because the value of k is 5. Now since we don't have anything, what I'll do is I'll just put the value null for the remaining part answer. If you see, this has a size 0, this has a size 0, and all these 3 have a size of 1. So we are still following the constraint that the value should be the difference of any two length of any two linked list, in this case should be at max 1. So now this is the whole idea, and now we are going to implement this in code. First of all, you see I have declared an answer array that would store our answer, and we would have a counter as count. So because we need the count of or the size of the linked list, right? We need to count the elements of the linked list. So what I'll do is I initialize a temporary variable, a temporary pointer to the side, and I'll count while this temp is null. So in this, I would by the end of this while loop, I would have the number of elements in the linked list in this count variable. Now what I do is I figure out the node per list. So how many nodes should be there per list, and that is count by k. And since I'm storing this into an integer, it would not take the floor. Basically, yep, the floor won't, yep, yeah, floor is correct. So since I'm storing this into an integer, the value of floor would be stored in this. Similarly, I take the modulo operation to figure out the number of extra nodes per list. So this would keep track that like in this case we have one extra in this, right? In this we have 3 extras, the first 3 elements. So this extra would keep track of that. Now again, I declare a pointer named traverse that would be going through the linked list, and I initialize that to head. And while this traverse is not null, that means there is a valid node in the linked list. First, I take that as a part of my answer. In our answer list, we need to have all the heads. Now nodes is node per list minus 1, and if there's an extra, nodes plus plus, right? Now why am I doing this nodes minus minus? So let's say in this case, you see this test case, we have node per list as 3 as we calculated. So I'm starting from here. So one jump, 2 jump, and let's say if I jump 3 times, basically we are jumping, right? Jumping the nodes. So we have to go to the node that is one element. So basically we have to go to the last element, right? So there are 4 elements, but we have to jump only 3 times, right? Because we are already at 1. So 1 jump, 2 jump, and 3 jump. So if we have a size of 4, we have to do 3 jumps. If we have a size of 3, we have to do 2 jumps. So that is why this is minus 1. So this, the number of nodes is n, the jumps is n minus 1. That is what I'm doing. And if I have an extra node required in this, what I'll do is I'll increment this nodes by 1 because I have one more node, and I'll decrease this value of extras. And now what I'll say, while nodes, right, while this number nodes is greater than 0, I'll just traverse the linked list and reach the last node of this so-called splitted linked list. And what I'll do is I'll store the next element, whatever it may be, and I would reassign that to null, right? We have to reassign this splitted linked list, right? That is what we are going to do. And I'll just change this traverse to next, and I'll go through this till the time the elements in the linked list are not finished. And for some reason, if the answer.size is less than k, that means we still need a few more elements, and that would be only this would only be the case when you're having the value of k more than the size of the linked list. For that, this is less than k, you push back null, and in the end you return the answer. Now this is the straightforward solution, and there were two test cases which were running, and I made three of them just to test some of the corner cases if they are working or not. So what if the case where k is 1, where we have to return the linked list? If this is working, you just do a dry run by hand. This is what I did, and I just verified this again. Now I again tried the same thing. This is not a corner case, this is already working in case 2, but I just tried to doing this for a larger value of k. Now the last one is, what if the head is empty? We have an empty linked list, so in that case it should also work. So if you see, this is working pretty fine. The corner cases that I thought is fine as well as if you see, it beats 100%. So what do you want more from this? Anyway, so yeah, let's discuss the time and space complexity before ending the video. First of all, we are traversing the linked list once, so big O of n, and again we are going to traverse this linked list again, so big O of n again, big O of 2n till now, and the space complexity is big O of k because we are storing a vector of answer, right, size k, and that is what we are going to return. I'm not taking the size of the linked list itself. So what I'm saying is the answer vector that we have declared is taking the size of k, and we are traversing through the linked list twice. So this is a two-pass solution. Fine. Suppose you knew the size of the linked list, right? So you could get rid of this step and you could directly proceed with this node pull list and extras. Otherwise, the time complexity is big O of n, which is the number of nodes in the linked list. The space complexity is big O of k. Yep. But for some reason, if the size of n is less than k, right, so this while loop would be dominating the time complexity. So you could say the time complexity is big O of max of n comma k. Whichever is greater, you choose that one. So if size of n is greater than k, you won't be even going into this while loop. But the size of linked list is less than k, you'd go through the linked list, and then you also will go through through this while loop as well. So in that case, your time complexity that would be big O of n comma k, max of n comma k. But if you see, number of nodes is from 0 to 1000 and k is from 1 to 50 itself, right? So if you want, you can ignore this k and just say that it's big O of n and the space is big O of k. Yep, that is the whole video. Hope I was able to explain this to you. Yeah, this is deserving of a medium level because you have to keep track of the number of elements in the list. By medium, it's not that difficult. It's the only difficulty lies in the implementation of your solution. So if you are able to figure that out, it's easy. Okay, again, I'll see you in the next video. Thanks for watching and bye.